Alright, so factoring, just understanding the word factoring. Is where we're going to take something and break it down into pieces. So we have something bigger, like this standard form quadratic, x squared plus bx plus c, and we're going to break it down into smaller parts. That's what factoring does. Alright, so we can see we are going to be working with standard form quadratics most of the time. Okay, we will not see vertex form ones. What we're really trying to do with this is we're trying to take the standard form and turn it into intercept form, where we had like x minus p, x minus q in the two binomials. That's what we're trying to do on this. We're trying to get it into like two binomials. So it will look like intercept form, because when we are trying to solve the quadratics, we are trying to find the x-intercepts, where the graph, where this U-shape crosses the x-axis. And that, when we did the intercept form, was where p and q were. We used those letters to show the intercepts, the x-intercepts. They would be the solutions of the quadratic. So when we look at factoring, and I'm going to do this one here, it says factor x squared plus 10x plus 16. The first method we'll look at is the simple method. So it's going to be simple at first, but then we'll go on to a more difficult method in a minute. But right off the bat, it should be fairly simple. So we need to, I need to get this back to here. Okay, so we're going to first just start with the simple method with our two binomials. We're going to put two kind of empty parentheses down first. And since we have x squared, we need to break that apart into two x's. So x and an x in each one right up at the front. That's why it's so simple. Because you simply put the x's up front. Or whatever variable you are working with. It's not always x. But variables just go up in front. If it's a v squared, v and v. Okay, it's just very simple. The next part here, we need to get these two numbers that are going to be behind here, which is like the p and q numbers from intercept form. To find that, we need to ask ourselves a question. And let's write the question down over here on the side. The question is going to say, what two numbers multiply to give you C, the C number. In this case, it's going to be the 16. There's a little quotation marks here. So separate that. That's C. Give you C. And add to give you B. The B number in the middle, which in this case is 10. So in our problem here, we're basically asking this question. What two numbers will multiply to give us 16 and add to give us 10? Now why add and not subtract? Well, because this number in front of 16 is a positive. It's a plus. So if it was a minus, we would subtract. So that's depending on this side. If it says plus the C number, you're going to add to get this number here. If it says minus the C number, you're subtracting to get it. So we are adding because of this plus. So we just start thinking about what two numbers multiply to give us 16. We can try 1 and 16. Would that work? Does 1 plus 16 give us 10? No, that doesn't work. So let's try the next one. 2 times 8, right? 2 times 8 would give us 16. Does 2 and 8 work? Does 2 plus 8 give us 10? Yeah, it does. So 2 and 8. Now about the signs that are inside here. So since this is a positive, when this C is a positive, we will always have those signs be the same sign. They have to be the same sign because positive times positive would give us positive, and negative times negative would give us positive again. So right, negative times, when they have the same sign, it's going to result in a positive. We have a positive 16. Okay, and when we do 2 and 8, okay, 2 and 8 have to be both the same sign to multiply them and get a positive 16. Okay, well, is it going to be both positive or are they both negative? That's now determined on this one here. This sign in front of the B is the sign that they both are. They're both going to be positive. So they'll both be the B sign. They're both the same sign. They're both going to be that sign. Because 2, positive 8 would add to give us a positive 10x. Okay, if they were both negative, that would give us a negative 10x, and that wouldn't be right. All right, so at that point, we are done with this problem. That is, right here, our answer. And at that point, we would then go on to try to solve it, but we're not solving yet. We're just remembering how to factor at this point. Eventually, at the very end of this paper, we'll look at some where we're going to solve. So these two you're going to be doing here in a minute. I'll give you time to work on the ones here that have the circles and the arrows in the circle. Let's come down to the next one we're going to look at, which is very similar. The only difference is that your b is negative. And really it doesn't change hardly anything at all. We start off, it's all still simple methods. Still a is 1. When a is 1, that's when it's a simple method. If a was a number like 2, 3, 4 or something, that's when it gets harder. That's what we're going to see on the next method. But for now, when a is 1, it is the simple method, and it just starts it like this. So let me, oh, there it is. Yeah, it's already there. Okay. So it starts like this again. X is our variable, so x and x would just go up front here. And now we ask yourself the question, what two numbers will multiply to give us 12 that will add to give us an 8? So does 1 and 12 work here? 1 times 12 is 12. Does 1 and 12? No, 1 and 12 does not work. How about 2 and 6? Does 2 and 6 work? Does 2 and 6 add to give us 8? Yes, they do. So 2 and 6 are the numbers then. That tells us those are the numbers. They're both going to be the same sign. Okay. Now remember, we're adding here. This means when this is a plus, it means we're going to add to get that 8, which we did. 2 plus 6. We're not subtracting 2 and 6. We're adding 2 and 6 to get the 8 because of this being plus. But also when this is a plus, we know that they're going to be the same sign in there. This time they're both going to be this sign here, negative. They're both minus signs. Because if I think about negative 2 times negative 6, that gives us the positive 12. And negative 2 and negative 6 combined together to give us a negative 8. That's the middle one. You're multiplying to get this one, you're combining them to get the middle one. And that's essentially our answer. Now there is a way you can always check your answer for factoring. Factoring is always separated by multiplication. You notice these two parentheses are touching each other right next to each other. That means they're multiplying the first parenthesis times the second one. So you can multiply to check it. If I multiply, like with FOIL, if you remember what FOIL is, first, outside, inside, last, when you have two binomials, you may remember that from Algebra 1, maybe not. First terms would be just x times x. That would be x squared, which would give us this term. The outside would be x times negative 6. That gives us a negative 6x. The inside gives us a negative 2x. Negative 2 times x is negative 2x. And those two combine right there to give us the 8x, negative 8x. So that works so far. Negative 2 times negative 6, that's our last ones here. That would multiply to give us a positive 12, which is our last term here. So that just mentally, you can just do that. You can check it even mentally to see, are you correct? In case you made a mistake in there with a sign or a number or something. Now, FOIL is just a cute way of doing a double distributive property. That's basically what I just did. I did x times both of these. I distributed the x to those two. Then I took the negative 2 and distributed that to both of those. Okay, I just combined the like terms because I'm getting 4 terms there, and you combine 2 of them together for the middle one of the 8x. All right, this one down here, it says factor x squared plus 4x minus 21. The only difference here is now our c number is negative. We still going to start just like with every simple method one. Very good parenthesis. So I'll start like that. So simple method starts off with 2 parentheses. I'm just going to 2 binomial parentheses, and letter is x again. So x is going to go up in front. That's how we always start our simple ones when it just starts off with x squared. Now we got to ask ourselves the question for these numbers. What two numbers multiply to give me 21? But this time, because that's a negative, we are going to subtract. Subtract to get 4. So does 1 and 21 work? 1 and 21. If I subtract those, do I get 4? No.
No.
What would be the next one?
7 and 3.
Okay, 7 times 3, or 3 times 7. That multiplies to give us 21. Do they subtract to give us 4? Yes, they do. So you're going to put a 7 and a 3 in here. It doesn't matter what order you put them in, whether you put 3 first like I did, or you put the 7 and the 3. Okay, that won't make any difference. As far as the signs go, now because this C is now negative, means we're not going to have the same sign. We'll have different signs. One will be negative, one will be positive. They have to be different signs because think about it. We're trying to get a negative 21 with 7 times 3. They can't be the same sign. That would give us a positive 21. They have to be different signs to get a negative 21. But now you have to decide, okay, well, which one gets the negative, which one gets the positive. That, again, goes back to your middle sign here. This base term is positive here. This sign is always given to the bigger number. So between 3 and 7, which one's bigger?
7.
7's bigger. 7's going to get the positive then. So 7 gets the positive, which means 3 gets our negative sign. Have to be opposite. Negative 3 times positive 7 does give us a negative 21. Again, you can check it with the FOIL. X times x is x squared. I just checked for that negative 21. Outside is positive 7x. Inside's negative 3x. So when I put them together, I'm going to subtract that and get a positive 4, which is correct. That shows me I'm right there. Okay, so far that was the simple method. When you just have, in front here, there's a number is still 1. When a is a 1, you don't see the a, so you know it's a 1, then you just do this, the simple method. Just got to remember that question. What two numbers multiply to give you c? And will either add or subtract depending on the sign of c. If it's positive, you add. If it's negative, you subtract. That will give you that b term. Okay, you'll come back. I'll give you some time to work on these ones on your own in just a moment. Let's go down to the bottom where it says factoring out the GCF. So factoring out GCF. GCF stands for what again? Does anybody remember what that stands for? What does GCF stand for?
Greatest common factor.
Greatest common factor. Good job. Greatest common factor. Let's write that down. This is for greatest common factor. So common means they have something in common. All the terms have something in common. And greatest just means it's the biggest thing they would have in common. If they have two things in common, then you want to go with the biggest one. That's just greatest means. So looking at the three terms here, we have 3 again. It's a trinomial. We call these a trinomial when there's 3 terms. If there was just 2, we'd call it a binomial. Okay? So when you have a trinomial here, 3 terms, they could all have the same letter. Like if this 10 also had an x, that would be a common thing they would all have, an x. And you can factor out an x then. If x is in all of them, then you can take an x out. They might even have more than one x. They might have like an x squared that you can take out. If you have, like an x to the 4th here, an x to the 3rd, an x squared here. So there's a lot of x's in all of them. You just factor out the smallest amount. Whichever one has the smallest amount of x's, of variables, you could do that too. We'll see some eventually where we'll do that. But on this one, there's nothing to factor out as far as the letters, but the numbers, 5, 15, and 10 are your 3 numbers here. Do they have a number in common? What can go into 5, 15, and 10? 5 can, right? 5 goes into itself. 5 can go into 15, and it can go into 10. 5 goes into itself how many times? Just once. Into 15 how many times? 3 times. Into 10 how many times? 2. So that's what we're going to use. So we're going to start with factoring out. Since 5 can go into them, 5 means 5 can be factored out of all of them. So we're going to put the 5, our GCF number, outside of this parenthesis. Remember, factoring is always connected or separated by multiplication, 5 times this parenthesis. That's why we don't say 5 plus or anything, it's just 5 and then parenthesis. Now, when you're factoring out the GCF, you can divide by the GCF to figure out what's going to be left, but we already kind of talked about it. If I divide this first term by the GCF 5, 5 goes into 5 once. So this becomes a 1x squared, or I can just say x squared. 5 goes into 15, we said 3 times. 15 divided by 5 is 3. So that middle one's going to be a 3x. And then 10 divided by 5 is 2. We said 5 went into 10 2 times. So this last one is a plus 2. Notice we had a trinomial here. We still have a trinomial here. You can't now have a binomial, so you can't forget anything. Even if you say, even if this last one was a 5 and you had 5 over 5, you couldn't just leave it off. You still have to say plus 1. Now, you still have to have the same amount of terms. Now, you might think, okay, great, we're done. But not necessarily. Sometimes you might be. You always make sure that when you're factoring, you factor it completely. You want to make sure you don't leave anything that can still be factored. So we have this trinomial, and that looks like the simple method. So you want to check to see, can it be factored with the simple method? So we'll start by putting the 5 down here again. Put those 2 binomial parentheses that we did with simple method. X squared would be x and x in front there with that simple method. That's just the setup part. Now we get to ask ourselves that question. What 2 numbers would multiply to give us 2 that add to give us 3? Well, this one only has one option, which is just 1 and 2. But does it work? Does 1 and 2 work for adding to give you 3? 1 plus 2 gives you 3?
Yeah.
Yes, it does. Works. So yes, this can still be factored some more. We can factor this without the simple method. Our signs have to be the same because it's a positive 2 there. They're both going to be the B term sign, which is a positive sign, so they're both positive in here. That's the final factoring. That's what we would want to say is our answer. If we did this and left this as our answer, we didn't factor it completely yet. It's not fully factored. We always got to make sure we get it down to, all of it being factored where nothing else can be factored anymore. We can't obviously factor a number anymore, it's just 5. And we can't factor x plus 1 anymore or x plus 2 anymore. They're done. All right, now on the other side of the paper, there is 1 there from 1 through 6 that is going to be where it's got a GCF. Number 1, you might want to put the little GCF right next to that number 1. So you know that's a GCF 1. Everything else is going to be, doesn't have a GCF on any of those other ones. So the only one that you have to do with a GCF that I see right now on the front page, at least, is number 1 right there on that right side. Okay, we're going to come down to looking at the star method now, and once we finish the star method, then you can go on to finishing all the ones on the front side that have those little arrows inside of the circle, inside of the dot. All of those ones you're going to do on your own. Okay, star method means we do have a number A. That's why I highlighted A there. There is a number there, as you can see on letter A, there's a 4, on letter B, there's a 3, and on this one down here, there's a 2. So there is a number there in front, and when there's a number there, it does make it more challenging. So this star method, let's write it down here. Let's put the star down first. So underneath A, just draw an X, nice big X like that, and then a line straight through the middle. Okay? Now I'm also going to do another one right up here, so kind of up in the upper right part up here. I'm going to do another one. And this one up here, I'm going to just use our ABC letters. Down here, I'll actually do the problem. So there are 6 sections. There are 6 different sections in this star here. We're going to first deal with the very top section up here. That top section, what you'll do is you're going to multiply the A number and the C number. It's going to be A times C. So on our problem here for A, that's going to be 4 times 3. So what number do I put up there?
4 and 3.
Well, what is 4 times 3?
12.
12. Okay, 4 times 3. It's going to be the A right here. A times C first on the top. Is it a positive 12 or negative 12?
Positive.
Okay, it's positive. They're both positives. Let's put the positive sign. I think it's going to be helpful. Normally we don't put positive signs. If it's just a number, we just leave the number. But I think the positive sign will actually be helpful. If it's a negative sign, we would know we would put it anyways. The bottom now is our next part to set up. That's going to be our B number. Whatever B is goes down there. In this case, B is what number? 13. And it's a positive, so I'm going to put positive 13. I think the sign will help us to see that sign. Now the top sides over here, the sides on the top sides are going to be exactly the same. They're both going to be the way this begins with the A number and an X. So it's just going to be AX, AX. Whatever the A number is next to X. Okay, on our problem, what's A? 4. So it's a 4X and a 4X on top of each side. The bottom of the sides is now where we're going to have to ask kind of almost the same question that we asked from the simple method. Let's write that question down, though, in this term. We're going to say, what two numbers multiply to give you A times C? That's the top number that you have, which is 12 in our problem here. So what two numbers multiply to give you the A times C, and add or subtract? Okay, that will depend on the sign of that A times C at the top. In this case, it's positive 12. So we're going to add on this letter A problem here. But you could subtract. So add or subtract to give you B again. B is at the bottom. So B is this 13 that we have at the bottom. So what two numbers multiply to give us the 12 that will add to give us the 13 is what we're asking. Does 1 and 12 work here? Yeah, 1 plus 12 does give us 13. So 1 and 12 are the numbers that we want to use. What sign should they both be? Well, they're both going to be the same because it's a positive 12 up here. We have to multiply them and get a positive 12, so they have to be the same. They're both going to be positive because the 13 is positive. So plus on both of those. Okay, the star is now completed, filled in completely, but there's one last thing to do with it. I'm going to write it right here. We must now reduce your sides if possible. It might not be possible, but reduce your sides if possible. Let's take a look at our sides here. We have a 4x over 1. Think of it as a fraction, 4 and 1. Would I reduce those? No, because 1 can't go into, you can't simplify that any further. 4 over 1 is just going to stay 4 over 1. So that is done. What about over here, 4 and 12? I think it as a fraction, 4 over 12. Could I reduce that? I could, right? I could reduce it by 4. So we would need now to reduce this by 4. 4 goes into 4 how many times? 12 3 times, but 4 goes into 4 how many times? 1 time. So 1x, let's just put just x here. And then 4 goes into 12, David, 3 times, right? Yeah. So positive 3 is at the bottom. So x over positive 3, that's now reduced, and that one's now done. Okay. Remember, we're trying to factor. Factoring, we'll want to get these into two binomials just like the simple method did. So we need to now take these two that I just circled and put them into two binomials. Watch how this works. Just put your two binomials down here. Empty parentheses, you can. And one of them is going to be a 4x plus a 1. See how easy that is now. Just 4x plus 1, you have them. The other one's going to be an x plus 3. It doesn't matter which order they go into. You could have put x plus 3 in the first one, 4x plus 1 in the other one. But that's our answer now. That's the final factoring of the star method with this. Of this trinomial, this factoring this trinomial with this a number of 4 is like this. We could check this by multiplying. 4x times x is the 4x squared. The outside's 12x, inside's 1x, which makes 13x when I combine them. And 1 times 3 is 3, for that last term for c. Now, I didn't always use this method. In fact, when I was in high school, we did a much different method. We would do just a guess and check method. And I would actually, when I started teaching, I was teaching that method until I came across this one. And since I came across this one, at first I was a little reluctant because I was just, you get stuck in one method. You just want to keep doing it. But I found that students were doing better using this method. And I think the reason why is because the guess and check, sometimes it could be faster. Sometimes I could do this faster with my guess and check method if the numbers are kind of small, easy to work with. But sometimes it could take a whole lot longer because you just keep guessing and checking different combinations. Let me show you how that would work with this one. You don't need to write this down, but I'll just show you what I would have done with the guess and check. I would start with those empty parentheses again, just like simple method. And I'd come to this first term, the 4x squared. And like our x squared, we'd have to break apart to x and x. I'd have to break this apart to 2 terms. 4 could either be 4 and 1 or 2 and 2. Okay, let's just say I chose 2 and 2, which I know is wrong. If I said 2x and 2x, that still multiplies to give me 4x squared. Okay, then I do the same thing with our last number, 3. Got to break that apart. Well, there's only one way to break it apart with 1 times 3. So I could put 1 and 3 in here. At this point, I have to check for my middle term. So I'm going to multiply my outside, which is 2x times 3, and get a 6x. Multiply my inside and get a 2x. Now, I know, just like the simple method, that I have to add to get this 13. Okay? I have to add these two to get this number. Obviously, 6 and 2 do not add to give me 13. So obviously, I knew that was wrong. Okay? I need to now make an adjustment about where these are, or my combination of things. I obviously can't adjust 1 and 3. There's no way that's the only option there. But I can change the 2x and 2x to a 4x and a 1x. That would still work like we have here. Obviously, we know that's going to be correct. But what if I did this and I put the 1x here and the 4x here? What if I tried that first? And now I check my outside and get a 3x. And I check my inside and get a 4x. And I'm supposed to add these together to get 13. And I see I'm wrong again. This is not going to give me 13. So again, I'm out there. Well, there's only one last thing I could change, and that would be where I put the 4x and the x. I could switch those, which I know that's what's going to be the right answer since I already did the star method up there. But I could do this now. I could say 4x and x here. Now I get my 12x, and now I get my 1x, and that's 13x. Okay, so I know that that's the right combination. I would just need to figure out what signs are going in there. I can see let's go off the same sign with the positive. They're both positive. So I do know they're both positive in there. And that's what I have up here. But, you think, I could have got that in one try. I could have figured this out the first time right away. Did 4x and x and put it in the right spots. That's true. You can get pretty good at doing it, and you kind of think about it and figure it out kind of in your head. But when you're trying to learn this, if the numbers get bigger, your options get more. Right now we had a 3, which is only one option with 1 and 3. Well, what if we have 4 or an 8? That gives you 2 options now. Or 12 would give you 3 options, like 1 and 12, 2 and 6, 3 and 4. Or something even bigger, like 24, gives you even more options. It's like 1 and 24, 2 and 12, 3 and 8, 4 and 6. It gives you 4 options. As the number gets bigger, the options get more. The more the options, the more chances for you to take a long time before you get the right combination. So you can do it this way if you like to, but I think this way is more straightforward and direct. If you just remember the star method, you can get directly to the 2 factors that are definitely going to be in there. And then you can just double check it real quick just in case you may have made a mistake with a sign error, or maybe you made a mistake with a number that's in there for some reason. All right, let's go on to this letter B. Let's try the B. Now, I know I spent quite a long time on this first one. We'll do this one a lot faster now that we know the method. So first start with your star. We'll start with drawing the star down. Start with the top of the star, which is A and C. A times C is 3 times 2, which is 6. Positive 6, I'm going to put the positive there. What's my B number down here? Negative 7. Top of each side is going to say A and X, 3X. So it's 3X on top of each one. See how that can go fast. That's just the setup part. You're just setting up your star. Now you're going to ask yourself the question for down below here on the sides. What two numbers will multiply to give you 6 that add to give you a 7? Well, 2 and 3 don't add to give you 7 though. That gives you 5. 6 and a 1. So I'll put a 1 and a 6, or you could do 6 and 1. That's fine like that too. 1 and 6, 6 or 1. Now as far as the signs go for those two, they have to be the same sign because you got to get a positive 6 when you multiply. They're both going to be this sign. They're both going to be a negative 7, the sign of the negative 7, negative, for both of them. So you can kind of just double check real quick. Negative 1 times negative 6 gives you positive 6, and negative 1 combined with negative 6 gives you negative 7. Now you just have to make sure you don't forget about reducing your sides if possible. This first one right here cannot be reduced. We are done on the 3 over 1 part. That is done. That's going to be going in our answer. But over here, 3 over 6 can be reduced. So we're going to reduce this by 3. What's the top going to say? Just an X, right? 1X or just X. What's the bottom going to say?
2.
And we'll put the negative sign with the 2. Yep, 3 goes into 6 2 times, but we can't forget about the negative to bring along with it. So X over negative 2 is now done. That's now simplified and reduced. I'll go ahead and put my answer right next to this up here. Plus 2 binomials. First one, it doesn't matter which one you put first. I'll put 3x minus 1 first. And then x minus 2 second. And again, you can double check by just multiplying that just to make sure you get this as an, when you multiply, you should get this trinomial. The 3x times the x is 3x squared. Outside is negative 6x, inside is negative 7, or negative 1x. That makes a negative 7 you combine. Negative 1 times negative 2 is the positive 2. So you can always double check that. Okay, one last one we'll try together, and then I'll let you work on things on your own. So drawing a star here. What number is going to go on top?
Negative 14.
Negative 14. Because A times the C. 2 times negative 7. What goes on the bottom?
2x.
No,
On
not
the bottom?
on the bottom. What is it? Negative 5. The B number, right. Negative 5 goes down there. It's the B number, just like it says here. B is on the bottom. And then on the top of the sides here, that's what you were saying. The 2x, yes. 2x. AX is on top of the sides. And then we ask ourselves the question now for the bottom sides. What two numbers multiply to give me 14? That will subtract to give me a 5. What will work there?
2 and 7.
2 and a 7. 2 and 7 multiply to give me 14, and 7 minus the 2 will give me a 5. 2 and 7 are the numbers. And then as far as the signs, should they be the same sign or different signs?
Different.
This time they're different because it's a negative 14. You have to multiply them and get a negative number, so they have to be different signs. So how do we know which one's going to be negative and positive?
With the 5.
What the 5 tells us that the sign of the 5 will be given to the bigger or the smaller one?
Bigger.
Bigger. 7's bigger. So 7 gets the sign of the 5, which means 2 has to be positive then. Now the last thing to do is just make sure we don't forget about reducing our sides, because if we just plug these in now, that's not going to give us the right answer. We have to make sure our sides are reduced. This second side is reduced. 2 over 7, there's nothing more I can do there. That's ready to go. But 2 over 2 you can reduce. So this here will reduce. What's the top going to say?
X.
Just an x, right? 1x will just be an x. What's the bottom going to say?
1.
1. And we got to put something down there, right? We can't just leave it blank. It's going to have to be 1. 2 goes into 2 one time, so plus 1. So now that one's done. And now we're able to put those into our two binomials for the final factoring. I'll put it right here. Yeah, right here's fine. So I could put this one first, x plus 1 if I want to. It doesn't matter which one I put first. X plus 1, and one of them in the other one, 2x minus 7 goes in the other. So that is how you can factor when you see an A number in front of your trinomial. Okay? When you don't have that A number and it's not there, it's just x squared, then you're using the simple method and it's a lot faster. But this one is the star method. Alright, so take some time now. I'm going to give you some time to just all the ones here on the front side of the paper. I'm not going to do the back side until tomorrow. So all the ones on the front side of the paper, finish those up, and then eventually I'll go over the answers with you just to double check that you got those correct. But again, you can always check your answers by multiplying, right? If you multiply them, you can always check those yourself.